So I'm going to go over some different problems we did in Unit 1. What I will remind you throughout all of this is that while this will go over some, please remember that you do have detailed notes and everything over all of these topics back in Unit 1. So this is a refresher. Your Pear Deck will have more problems for you. And then should you have any other questions, you can go to your old notes. You can go to Canvas to see the old notes. You can reach out to me, whatever you may need. So you have plenty of resources throughout this. Just make sure to keep those in mind. In Unit 1, it was primary linear equations, as we talked about in the overview in the last video. So one of them was our absolute values. This is one that on your pretest many of you seemed okay with, but I do want to take a second to go over it just in case, especially since we won't be in school together this week. First off, you want to always isolate your absolute value first. So I'm going to add 7. So it'll be negative 7 equals negative 7, and then we're going to divide by that negative 7, and you'll have the 5n plus 1 equals 1. These problems always then split into 2, because 5n plus 1 could equal 1, and then this equation would be true, but your 5n plus 1 could also equal negative 1. Since this negative 1 would be in the absolute value, you do the absolute value of negative 1, and you get 1. And so we're going to solve both of these. So 5n plus 1 equals 1. You get 5n equals 0, and n is 0 is one of your two answers. And then when we solve it again, 5n equals negative 2, n equals negative 2 over 5. One thing you will also want to identify, and typically moving forward I will do this first, not at the end, is the domain of your possible answers. This is, when it boils down, is a linear equation. And as we talked about in the review video, you can plug anything you want into this. So I expect my answer will be literally anything. I don't have any constraints on my answer. And then my actual answers that I got are this 0 and negative 2/5. So as we look at this one, again, this is just a linear equation. It's an inequality this time. But because it is linear, there's nothing in a denominator, there's no logs, there's no anything else that would give us an issue. A radical, my domain is anything. My answer could be literally anything in the world. And so we have that in mind going into it. We're not going to be surprised by any type of answer. When I'm doing this, I purposely picked one that has some pretty ugly fractions. First, what I would do is get rid of those parentheses, so I'll distribute that in. We will do 15 times 8, and you get 120 over 4 times 3 is 12. 15 times 3 is 45 over 4 is greater than 115 over 12. We talked about these a little as we went throughout the year. What I would do is clear those fractions. So one of the reasons I didn't simplify this first one is because now I'm really just looking and I'm going to find my LCD, much like we did in Unit 4. My LCD of this inequality is 12, and it's really going to go next to all of them. And you're going to cancel out those denominators. This is going to be negative 120x. What I always do with this next one is I do the division first. 12 divided by 4 is 3, so I'm really just doing 45 times 3 is 135 is greater than 1115. While my numbers are big, it's nothing we can't handle. 1115 minus 135, sorry, gives me 980. We're going to divide by this negative 120, and we get negative 8.1667. And again, our inequality flips. One thing you will notice if you look at that overall review is ideally in this chapter, I don't want decimals if we can avoid it. I want them left as fractions. So I'm going to talk that through with you for a second. If I hadn't typed this in my calculator, I would have just had negative 980 over 120, and then you're really just working to simplify this. Those zeros can really cross off because that means they both divide by 10, and then you're just figuring out what goes into 98 and 12. It's going to at least be 2. 98 divided by 2 is going to be 49. 12 divided by 2 is 6, and then this doesn't simplify at all. So the answer I would want is this negative 49 over 6. When you graph it, the decimal can help to know where this goes. Negative 8.1 is just past 8. It's going to be an open circle. X is less than, so I'm going to shade to the left. Okay, so this is the actual answer for my function. Anything less than negative 49 over 6. Oops. Oh, I forgot to flip it over here. I apologize. This should have been still less than. I expected it to be any numbers. This follows into that, and so we are good. With ones that are compound like this is really an and inequality, which means that both inequalities have to be true. Both that this negative 7 is less than 2m minus 5, and that 2m minus 5 is less than 5. If they're written together, you can take advantage of that and really just solve it all at once. So for example, since I would have to get m alone, I would add 5, and I'm just going to add 5 in all 3 spots. And it's going to give me this, and then I would divide by 2 in all 3 spots. And so this would be my inequality. Okay, when I go to do that, it's going to be a closed circle on negative 1, an open circle on 5, and how this reads is negative 1 is less than m, which means that this m is really bigger than negative 1, and m is less than 5, so it's these values in between. It's the values that satisfy both inequalities. Apologize that I forgot to do the b. The domain for this, again, it's linear, so the domain is just negative infinity to infinity. Any answers would work for m. Again, we just really have to guess and check until it works. The specific answers that do work and give us a correct value are anything between negative 1 and 5. We also talked about absolute value inequalities in this unit, and so we'll go over this a little bit. You started out the same way of isolating your absolute value. So I'm going to add 4, divide by 4, and I get an absolute value of negative 5 plus 4n is greater than or equal to 21. And then we still split it into 2, but we had to do a little bit more work with it. First off, you just drop all the inequality, or drop the absolute values. For the second one, you have to drop the absolute value. You have to flip the inequality and flip the sign. But we also have to think about whether this is an and or an or. If it is greater than, it is an or. Again, greater than when you split it. If it was a less than, it would be and. So it is important when we graph this that we're thinking about an or, not an and. But then we're just going to solve it like normal. I would add 5 equal to 26. N is greater than or equal to 13 over 2 when you simplify that fraction. Solving the other one, I would add 5 for n is less than negative 16. And then n is less than or equal to negative 4. What's important is this needs to be an or. So when I go to graph it, 13 over 2 is about 7.5. So I'm going to put that here. It is a oopsies, wrong side. Apologize, it should be right about there. Negative 4 is all the way over here. Because it is an or, they don't have to overlap. It is anywhere you would shade either of them that will work. So greater than 13 over 2 would be to the right. Less than negative 4 would be to the left. And it's okay that these overlap because they don't have to. It's just wherever you would shade at all. So that would be my solution. Anything greater than 13 over 2, anything less than negative 4. The domain, again, is the same for any linear equation or inequality. You could plug in anything you want. They won't all work. What will work is the things in these shaded regions. So I'll try this one as well. If you are feeling confident and you want to give it a try, feel free to, and then play it to listen to me explain it. Here I would add 1 and get negative 14, divide by 2, and you get 3n plus 8 is less than negative 7. And we do have to split it. You split it primarily the same way. 3n plus 8 is less than or equal to negative 7. 3n plus 8 is greater than or equal to positive 7. Because this is a less than, it needs to be an and inequality, which again we will keep in mind when we graph it. But if I go about solving, subtract the 8, 3n is less than or equal to negative 15. So n is less than or equal to negative 5. Here 3n is greater than or equal to negative 1. So n is greater than or equal to negative 1/3. When I go to graph this, n is less than or equal to negative 5, be that region. N is greater than or equal to negative 1/3 would be this region. What's important it is an and, so your only solutions are where the overlap is. These two do not overlap at all, so this would be no solution because there is no overlap and an and requires overlap. For the domain, again, it could have been anything because it's linear. In this case, it just works out that nothing will satisfy that equation. Last but not least was a favorite back when we did this in the unit, so a systems of 3. Just to make sure we remember these, because again, moving forward in upper level classes, you will have to be able to solve a systems of equation, so we want to make sure to review that. So you've done it since August. With these, first you need to pick one equation and solve it for one variable. So looking at this, I look at this top equation because it already has just 2 variables. Maybe I want to solve for z. Here you can technically pick whatever you want, so keep that in mind. But if I solve for z, I get negative 3y minus 3. What I'm going to do with that then is plug it into both other equations for z. And this is where some organization is going to be key. So I would have 5x minus 2y minus 4 times negative 3y minus 3 equals negative 18. And I'm going to condense this a little bit. 5x minus 2y plus 12y plus 12 equals negative 18. And a little bit further, just to put my like terms together and maybe get my numbers all on one side. This is one equation that I'm going to use again in a minute. I need to come up with my second one though, and that is from plugging z into the bottom one. So I'm going to have negative 4x plus 6y plus 3 times negative 3y minus 3 equals 10. Again, going through and simplifying a little bit. And then putting some stuff together, negative 4x minus 3y equals 19. That's my second equation. Okay, the most common mistake is just arithmetic errors as you go through. So please be careful as you do these. Check your negatives, check your combining like terms, all of that. Now, it's really like we just have a system of 2. This red and green equation, I'm going to be able to solve that by substitution as well. So I'm going to pick one of the equations, whatever looks like it might be easiest to solve for one variable. And to me, I'm going to solve this green one for x because I know I'm eventually going to have to divide by 5, and all of these numbers are divisible by 5, so I'm going to void a fraction. So 5x equals negative 10y minus 30. Divide by 5, and you get negative 2y minus 6. I will now plug this in for x in my red equation and kind of repeat the process of what we did a minute ago with the blue into the other 2. But now what's going to happen is I only have one variable, and so I will actually be able to go all the way through and solve this. I'm going to have 8 minus 3 gives me 5y. I'm going to do 19 minus 24, just so I don't do anything silly. Typed it in. And then y equals negative 1. Now I get to backtrack and start finding everything else. First thing I'm going to do is take this negative 1 and plug it back in to solve for x. I'm going to have negative 2 times negative 1 minus 6. Negative 2 times negative 1 is positive 2. 2 minus 6 tells me that x equals negative 4. And then I'm also going to go all the way up to the top. I plug it into this blue one, but you can technically plug it in wherever you want. If I plug in my -1, 3 minus 3 gives me 0 for z. And again, we write our answer as an ordered triple. It always goes in alphabetical order. Oopsies, can't close that yet. And that would be my final answer.